Hello everyone, let's prevent a solution given this nice exponential equation, which is x to power of x to base 3. This is equal to 81. So what is the value of x? Now solution from what we have here, x to power log x to base 3, this is equal to 81. Okay, now to solve for the value of x, we introduce the natural logarithm on both sides such that we'll have log x, okay, to power log x to base 3. This is equal to log 81. Now from here, you find that log x to power log x to base 3, this is in the form of log a to power n, which you can express as n log a. Okay, so this is the power rule property of logarithm. So applying this property, we will have log x to base 3 multiplied by log x. This is equal to log 81. Okay, now from here you find that log x to base 3, this is in the form of log a to base b, okay, which we can express as log a divided by log b. Okay, now from here you find that we will have log x divided by log 3 multiplied by log x. This is equal to log 81. Okay, now from what we have here, we have log x times log x. This is equal to log x raised to power 2 divided by log 3. This is equal to log 81. So let's proceed. So we have log x to power 2 divided by log 3. This is equal to log 81. So we can express 81 as 3 to power 4. Okay, we can express 81 as 3 to power 4. Substituting this, we'll have log x to power 2 divided by log 3. This is equal to log 3 to power 4. Now, applying the power property of logarithm, that is log a to power n, which we can express as n log a. So applying this property, we'll have log x to power 2 divided by log 3. This is equal to 4 log 3. So you're saying that log 3 to power 4 becomes 4 log 3. Now we multiply both sides by log 3 to eliminate this log 3 here, and also the other side by log 3. Now from what we have here, we simplify so that we'll have log x to power 2. This is equal to 4 multiplied by, we have log 3 times log 3. So that means this is log 3 to power 2. Now the next step is to determine the square root. We just introduce the square root on both sides. Okay, so that from what we have here, log x to power 2, okay, we can eliminate the square root side so that we'll have log x. This is equal to plus or minus. This is equal to plus or minus. Now here we have the square root of 4 multiplied by square root of, this is log 3 raised to power 2. So we have square root of 4 multiplied by square root of log 3 to power 2. So now we'll have log x. This is equal to plus or minus. Now square root of 4, this is 2 multiplied by, now this is the same thing as log 3 to power 2 eliminate. We'll have log 3. Now that means we have two possible values of log x. We have the first log x is equal to 2 log 3. You can call this equation 1. And we have log x is equal to negative 2 log 3. We call this equation 2. Now we are saying that we have two equations from equation 1, which is log x is equal to 2 log 3, and equation 2, which is log x is equal to negative 2 log 3. Now from equation 1, okay, from equation 1, we have log x, this is equal to 2 log 3. Now we can be able to write this in terms of logarithm notation, which we can express as 10, okay, to power log x to base 10, okay. This logarithm is under base 10, okay. So this is equal to 10 to power 2 log 3 to base 10. Now, as you can see, 10 to power log x to base 10, this is in the form of m raised to power log a to base m, which is essentially equal to a. Applying this logarithm property, we'll have 10 to power log x to base 10. This is the same thing as x, which is equal to, now here we have 10 to power 2 log 3 to base 10. This is the same thing as 10 to power log 3 squared to base 10. We are saying that 10 to power 2 log 3 to base 10. This is the same thing as 10 to power log 3 squared to base 10. So from what we have here, applying this property, this is essentially equal to 3 squared. And that means that the value of x is equal to 9. That is the first value of x. The first value of x is equal to 9. Now from equation 2, we have log x, this is equal to negative 2 log 3. Okay, so applying this logarithm property, we'll have 10 to power log x to base 10. Okay, this is equal to negative 2, that is 10 to power negative 2 log 3 to base 10. Okay, now applying this logarithm property, that is m to power log a to base m, which essentially is going to give us a value of a. That means here we'll have x is equal to, now this is the same thing as 10 to power negative 2 log 3 to base 10 is the same thing as 10 to power log 3 raised to power negative 2, which is equal to 3 to power negative 2. And that means that the value of x is equal to 1 over 9. So here we have two possible values of x. One is 9 and the second one is 1 over 9. So let's verify if this value of x actually satisfies the equation. So let's verify that these values of x actually satisfies the equation. Now the first value of x is equal to 9. So if you recall, we end at x to power log x to base 3. This should give us a value of 81. So let's substitute the first value of x, which is 9. So you'll have 9 raised to power log 9 to base 3. Okay, now this should give us a value of 81. Now we can express 9. 9 can be expressed as 3 to power 2. So we can write this as 3 to power 2, okay, log 3 to power 2 to base 3. This should give us a value of 81. Okay, now 3 to power 2, this is a power. Okay, so we can take this power and we can just take this power here. So we'll have 3 to power 2 multiplied by 2 log 3 to base 3. This should give us a value of 81. Okay, now from what we have here, log 3 to base 3. This is in the form of log a to base a, and log a to base a, this is equal to 1. Okay, so this means that this is 3 to power 4 multiplying by 1. This should give us a value of 81. So this is 3 to power 4. This is equal to 81. And it's true, 3 to power 4 is equal to 81. So that affirms that the value of x, which is equal to 9, actually satisfies the equation. Let's check x is equal to negative. That is, x is equal to 1 over 9. Let's check. So we'll have 1 over 9 to power log 1 over 9 to base 3. This should give us a value of 81.